My name is Matthew Mary. I'm a program manager on the Windows Runtime team. And in Windows 7, I worked on a little technology called RPC. I was also the program manager for COM. In Windows 8, I've helped build a lot of this infrastructure that we're going to show you today. So it's a little bit about my background. What we're going to do here today is we're going to really get into some deep internals of your application, and we're going to get into some internals of the operating system and how the operating system interacts with your application. Now you may be wondering, okay, so if I understand really well how my application works internally and all of its guts, what does that have to do with the Windows runtime? Turns out that your application is just another Windows runtime object to the operating system. It's an interesting point, and we're going to be getting into that in detail. Now, what I'm going to show you, you do not need to know any of this in order to build great applications. You need to know none of it. We're going to go into really low-level detail. We're going to be in the debugger. We're going to be looking at virtual function tables and figuring out how Windows runtime interfaces work. We're going to be in the registry. We've done a lot of really good work in Windows 8 to make building these new Metro-style applications really, really easy for you guys, the developers. This is not anything that you need to know. You don't need to repeat it. You don't need to be able to, tell anybody else. But if you're kind of curious to know what's going on within the OS, then this talk is absolutely for you. We're going to get into those details. Hopefully you're going to come away with some of that curiosity satisfied of what's going on under the covers. And if you build a DirectX application, if you're building a C++ application, then some of what I'm covering is going to be applicable directly to you. You'll see some of the interactions with the core application object, and your C++ app will actually be doing that. And with this knowledge, hopefully, you can build better applications. And heaven forbid, our developer preview operating system may have some issues, and it may also give you some touching points on, where would you start debugging certain failures. So with that said, if you don't want to know about the details, and you don't have to know about the details, please leave. We got lots of people lining up in the back to watch the talk. Jumping right in, when I say the Windows runtime, to you, the audience, the Windows runtime means those APIs that we've produced that you can consume from those languages of your choice, JavaScript, C++, C#, VB. That to you is the Windows runtime. Now I'm kind of an internals guy. I started my life off at Microsoft working on Endus, which is like the lowest layer of the operating system. So when I say Windows runtime, I'm thinking like the internals, actually the infrastructure that we've built that enables these APIs. Now, if you attended Martin Lovell's talk, he talked a little bit about that infrastructure. And he covered a lot of what's on this diagram. And we're not going to have time to cover everything on this diagram today. What we're going to do is we're going to focus on your application and how your application works with the Windows runtime infrastructure in order to run. Now, your application really has 3 stages, maybe 4 stages of its life cycle. Obviously, first you guys have to build your application, right? Before you have an app, you got to build it. Most of this conference, if not all of this conference, has covered building your application. So we're going to build a very, very small app, the most simplest app that we can build, and we're not going to focus anymore on building the app. What I'm going to focus on is what's going on inside the operating system when you install your application. We know we have a manifest, it's declarative. What does that actually do? I'm going to focus on what's going on in the operating system when you tap the tile, when you touch the tile for your application to launch it, and how your application process is bootstrapped. What's going on in the very first few instructions that your application process is executing. So this process all starts with install. We know from some of the previous talks that install is declarative. We have a package, an AppX package. We have a manifest in that package that describes all of your application's registration. But what we don't know is what actually happens in the operating system when we take that manifest and register your app. So we're going to get into that. And in order to get into that, the first thing that we have to do is we have to go and build an application. So let's go over to Visual Studio real quick, and I'm going to build the world's simplest app. So we're going to create a new project. I'm going to call this thing Hello World, like that. And we're going to make sure that it's a JavaScript application. It's just a blank application. We're not going to use any templates. So So let's let Visual Studio chew on that for a minute, and it's going to spit out some files. And we know Visual Studio is going to spit out the default.html file, it's going to spit out some JavaScript files, and obviously everything package-wise, it's all going to be there. Giving Visual Studio a moment to think about what I just told it to do. Eventually, it should create my project. There we go. Excellent, excellent. So here we have default.html, no surprises. And I'm going to put a little code into default.html just so that it does something, right? And you guys heard that this is a bold reimagining of Windows. It was even in our, financial announcement, so I better make my executives happy and call this Hello Bold New World. All right, so if we ran this thing, we would get exactly what we expect, right? It would come up, it would run, default.html would load, we would see that HTML page rendered. Before we do that, I want to take a look at the package manifest file. So we can open Solutions Explorer and dive into the package manifest. Now, Visual Studio has done a really, really good job of wrapping a very nice UI on top of that XML. The underlying XML that's your manifest, that is your manifest. And here's that UI, right? You can look through this. A lot of this stuff looks really familiar to you. Display name, description, tile, you can see all of your icons are specified here. You've probably poked around in this a little bit. Capabilities, you've heard a lot about capabilities. Right now my application is declaring the internet capability. Nothing new there. We have quite a list of capabilities. Declarations is interesting. If you guys are using search, share, play2, those contracts, and we're going to get into really good detail on what those contracts actually are. If you're using any of those contracts, you can find them here. There's one last thing that I want to point out, or actually two last things I want to point out about this. We have a package name. That package name right now is a GUID. I don't particularly find GUIDs very useful, so I'm going to rename this thing to Hello World Demo. Okay, now our package has a reasonable name. This is going to help us a little bit later on when we're tracking down where this package name is at within the system. Good, so we can save that. Now, this is the UI on top of the XML. We can actually go in and look at the XML if you guys want. So we can come in here, click on this, and choose View Code, and it's going to load the XML that is our package manifest. And we look through here and we see the things that we expect, right? We have a package identity. It's that name that I just wrote into the UI, right? We have a version, we have a version up here, no surprises. Here we have an application node. Now this small little, what is it, five lines-ish of XML describes my application's registration at this point. You can see that I have an application ID. Again, it's not exactly a really useful application ID, and for the sake of later in the demo, I'm going to change this. I'm going to call this Hello World App ID. All right. So we're going to see what these 5 lines get turned into in the next step. So we can go ahead and run the application. And you can see Visual Studio doing the normal packaging operations. And the key here is Visual Studio is actually deploying your app right now. All right? It took that manifest, it took that package, it registered it with the system, and we see exactly what we expect. Hello, new world. So we can flip back here. We can stop. The interesting thing is when I say it registered it with the system, it actually really did register it with the system. It's installed. You can see it in the start screen. So what do those registrations actually look like? Well, it's probably not a surprise to you. We store registrations in this thing we call the registry. I'm sure you've all heard of the registry. So we can go open the registry. And where would we find the registrations for these applications? Where would they actually be? We know that applications are installed per user. All of these new Metro-style applications are installed per user. So it's going to be somewhere under HKCU, HK current user. And I can actually turn on the screen magnifier because it's a little difficult to read some of this. So we know that it's going to be somewhere under HKCU. Now we could grovel around and search around and try to find it. Luckily, I know right where it is. We can come into HKCU, software, classes, and your application registration is somewhere in here. Now, the key thing here is there are 2 registrations for your application. There is an extension registration, and there is a class registration. Now, we know that applications implement contracts. We have the search contract, we have the share contract, play2 contract. Those contract registrations are extension registrations to the operating system. All right? Believe it or not, tile, your tile, when you click on the tile for your application, that's just another contract activation. That's the Windows.launch contract. So we can go into HKCU software classes, extensions, contract ID, no surprise, and we expect to see a bunch of these contracts. And sure enough, we see file, file picker, we see launch, protocol search, and we know that all applications have a tile. Tile is launch contract, so we should expect to find our application's extension registration in here. So we can expand this out, and everything is organized by package ID. And we can see that package. It's a little bit more information than what we specified in the UI, right? You can see it has the name. It looks like it has maybe the version. It has an architecture. It has some extra stuff in it. It has this weird collection of characters at the end. Looking into this extension registration, we can see that we have an activatable class ID. And under here, we have this hello world app ID.wwa. Now, this is the class registration for this extension. So we have extensions which say, hey, I implement this contract. I implement launch. And then we have classes. The extensions point to the classes. The classes are actually the implementation. When I mentioned at the start of this talk that all applications are just Windows runtime objects to the operating system, this is where all of that starts. All right? This is your Windows runtime class that the operating system knows about for your application. So we can look at this a little bit more, and we see that we have a bunch of interesting values here. We have a bunch of, under this registry key, we have a bunch of registry values that provide a little bit more context. We see we have the display name, we have a description, the icon points to the location on the disk where that icon is. All of this is good. But where the real interesting stuff is in that class registration for your application. So we should probably go back, and we should probably find where that class is, which is pretty easy to do. Let me turn off the magnifier for just a second. If we go back up, past extensions, we see that there's a registry key called activatable classes. This is where the class registrations for all of your applications are. We can take a look here. And again, we find our package. This is really interesting. All extensions, all classes are organized based off of your package. That means your package, your application, has its own unique set of classes. It doesn't share classes. It doesn't share extension points with other applications. They're all unique for your app. So we can drill in here, and we can start taking a look and say, okay, well, let's see what the class registration for my application looks like. Well, we have an activatable class ID. We knew we had one of those from the extension registration. We should expect to find that class in here. And indeed we do. There it is, hello world appid.wwa. Now we can come over here and look, and let's see what we got. This, by the way, is a WinRT class registration. This is the same registration for all WinRT objects on the system, whether it's your application, whether it's a class that your application produces, whether it's a class that we, Microsoft, produce. Same registration here. We can come in here and look at this, and we see that there's a couple interesting registration attributes. I'm going to talk about two of them. The activation type. Activation type here says 1. What does that mean? The Windows runtime supports two activation styles. It supports in-process activation, where you provide a DLL and we will load that in process. And the Windows runtime supports out-of-process activation, where you provide an executable and we'll launch the executable as your class implementation. This activation type of 1 here indicates that it's an out-of-process class. Out-of-process classes have a server. We have to know what executable, so there's a server registration here. Excellent. So if we go back, we remember we saw activatable classes, server. We could expand this, and we can expect to find, here's the server name. We expect to find the server. Here's where we're starting to get down to the metal. Inside this server registration tells the Windows runtime enough information about what code we actually need to slurp up off the disk and start running to get your app up and going. All right? This server registration tells you that the executable for your app, for the HTML app that we just built, that executable is a system-provided binary. It's called wwa host.exe. I don't know if you've noticed it yet or not, but all HTML applications run in wwa-host.exe, and there's one of them on the system. Each application will get its own instance of that executable, but they all use that executable. This is kind of interesting. We should probably go and try to figure out how does this WWA host executable know anything about your application, know anything about that page that we're going to load, know anything about that. We'll get into that in a little bit. But before we do, I think right now is probably a good time to come back and take a look at what we just saw. We saw that installation was declarative. We saw just a few lines of code for your application's registration. We saw that those few lines of code got changed into two different kinds of registration, an extension registration and a class registration. We saw in that extension catalog that's located in the registry, we organize it based off of contract. Those contracts in turn point to extension registrations. Those extension registrations in turn point to class registrations. It's those classes that have the code that we need to run for your app. All right? Now, why did we do this? This seems kind of bizarre. We have these two different registrations. Why didn't we just all put it into one registration? And there's a good reason for doing that. All right? The extension registration takes that abstract concept of a contract and maps it to something very concrete, a binary, an executable that is the implementation of that contract. It allows the system to maintain a nice orderly catalog of all the applications, all of the contracts that the applications have registered, and then point at the various implementations. So that's why we kind of have those two levels of abstraction. What actually happened there? Well, we had the manifest. We ran it through this deployment engine, this deployment operation. Visual Studio, in this case, did it when we hit F5 with Visual Studio. Under normal circumstances, this would be all driven by the App Store, right? And we populated those two catalogs. Now, I'm kind of cheating a little bit. I only showed you two of the catalogs. That's not all that happens during the deployment operation. There's a bunch of other catalogs. There's a bunch of other code that gets written during deployment. And we're not going to dwell on that because it's not really applicable to this talk. But just keep in the back of your head, this isn't all. I'm not showing you the entire picture for deployment. There's a bunch of other things that are happening. So that's great. We have our app on the system. We saw where it was registered, and we know a little bit about the application's registration. We know those registrations are really just WinRT registrations. It's very interesting. What happens when we tap on the tile for our application? Well, we could probably assume that those registrations are going to get read, and we're somehow, eventually, we don't know how yet, but somehow we're going to launch that wwa-host.exe file. And that's exactly right, but we should probably go into one more level of detail. Instead of understanding conceptually how it works, we should probably really get how it works. So we're going to go back and we're going to run our application here. So we can flip back. We don't need the registry editor anymore. Get the screen magnifier out of the way. We'll minimize that. We might use that later. So we can come over here. We can take a look. Actually, before I run the application, it would be useful to know what's going on with an Explorer. Now, Explorer is going to be responsible for, registering the tile touch that we do here and figuring out what exactly needs to happen. When I was planning this talk, I was thinking I was going to do some really cool stuff. I was going to attach to Explorer and start debugging Explorer live on stage, and all you guys, your eyes would start to glaze over. And this was working great in my office. I had 2 monitors, and I was going to town. I went home to practice, and things kind of fell apart. Turns out that when you're attached to Explorer and broken into it, you can't exactly Alt-Tab around Windows, so that makes it a little bit difficult. So we're not going to try to debug Explorer. But instead, what we can do is we can use a tool called Procmon, and we can use that to kind of keep an eye on Explorer and figure out what is Explorer doing. Is it actually going and reading that registration that we expect it to read? I set up a really simple filter. You can see what the filter is here. It's explorer.exe. I set the paths up to be those paths that we just watched. So if everything goes well, I can hit OK. Process monitor is running. I can flip back here, and I can now launch my application. And it comes up and it launches. Perfect, beautiful. Let's go back and see what process monitor found. So indeed, it was reading all of those registrations that we just saw. And you can see it going through here and enumerating all of the registrations. It's going through, it started in the extension catalog, right? It said, hey, I want to look in all of the implementations for Windows.launch. It found the package ID that we had registered. There's that package ID again right there. So it went through the extension catalog and found that extension registration. Explorer then went through the class catalog, because that extension registration points at the class. It goes through the class catalog and finds all the information about the class. So Explorer is doing exactly what we expected Explorer to do. Perfect. The application launched. It's running. It's right here. Whoops. Well, it was right here. Let me try that again. There it is. It's right here. The application's running. It would be useful to know exactly how that process still got launched. So Explorer did what we expected it to, read the registrations, and eventually the app got launched. So again, I can't really debug Explorer on stage very well. So what we're going to do is we're going to walk through a little bit of PowerPoint slideware to explain what actually just happened. Now, we saw that tapping a tile did the things that we expected it to do. We don't need to dwell on that anymore, right? And we know that eventually that caused the class registration that we saw, that caused that class to get activated. Now, the way that we implemented this is kind of interesting to me. It's interesting to me because I worked on it, and I hope it's interesting to you as well. There's a little bit of activation system within Explorer.exe that is monitoring these tile touches and performing all of the activation requests. Now, this is the interesting part. What that activation system does is it creates an object that represents our extension catalog. So it creates an extension catalog object. This is a Windows Runtime object. This is a Windows Runtime object that right now only the OS uses, but we use the Windows Runtime internally as well. So this is a Windows Runtime object, that's the extension catalog. Explorer is going to query this thing, right? You saw that it's going to hit the extension catalog, and it's going to find that extension that we're looking for, that Explorer is looking for. Once that extension catalog object finds what it's looking for, it goes and creates an extension registration object. Again, this is just another Windows Runtime object. So the OS is using these things internally, just like your application uses them. All right? Now, the activation system is going to take a look at this extension registration object and kind of make sure that it is the extension that it's looking for. Once it's satisfied that, hey, this is the extension I'm looking for, this is the application that I want to activate, it simply calls an activate method on it. All right? And that's when the Windows Runtime internals take over, and we start the process of activating your application. Again, there's a slight challenge with debugging this. In order to debug this on stage, I'd have to attach to a couple processes that if I screwed something up, I'd have to reboot my demo machine. I'm a PM. I'm not that great at debugging, so we're not going to take that risk. And again, we're going to kind of walk through this PowerPoint-wise. So when we call activate on that extension registration object, I mentioned that this is just WinRT activation at this point. What I'm going to walk through on this slide is what every out-of-process WinRT activation looks like. At this point, your application to the operating system is a class, and we're activating an out-of-process class. We saw the activation type in the registry. So what actually happens here? Simple. We call into this service called RPCSS. Now, this RPCSS service, some of you guys, if you're familiar with some older technologies like COM, you may know what RPCSS is. For the folks who don't know what RPCSS is, it's sort of the clearinghouse for activation on the system for WinRT objects and for COM objects. So it kind of maintains a list of all the things that have been activated and tries to figure out, oh, you're asking me for one of these new things, one of these new foos, right? Do I have a foo that's already been activated that I can give you? So RPCSS is going to look into that class catalog, basically Explorer saying, hey, activate me, what do we call it? Hello World App ID, right? Activate Hello World App ID. RPCSS looks in the class catalog, give me some information about that. Do I have one of those running? In this case, we didn't have one of those running because it was the first activation for our application. And RPCSS calls into DCOM launch and says, hey, DCOM launch, can you please start me a new instance of this class? Now, there's a separation here on purpose. RPCSS is a network-facing service, and it receives all the activation requests for your system. DCOM launch is able to start processes. We kind of want, a little bit of a separation a security boundary between the two, so they're two different entities here. DCOM launch, again, is going to say, hey, what's that executable? And eventually, DCOM launch is going to start that executable. It starts up WWA host. So internally within the OS, this is exactly what's going on when you click the tile for your application. This is our out-of-process activation system for the Windows runtime. And by the way, we didn't invent all of this for the Windows runtime. I had mentioned if you knew a little bit about COM, some of this would be familiar. This is also the out-of-process activation mechanism. In large part, we've changed a few things. In large part, this is the out-of-process activation mechanism for COM. So this was some existing technology that we had, and we've leveraged it for these Metro-style applications. Excellent. We got our app running, right? That process started up, it's running. But that still doesn't really tell us a whole lot. All that said was WWA host, that process is now running. We haven't really given it any information to tell it what it's supposed to be running. It's just an OS-provided binary. It's just an OS-provided executable. How does it know about every one of your applications? That's some more interesting implementation detail that we're going to get into in a little bit. So we should probably take a look at what's going on here. Well, the first thing that we can do is we can attach to the process that we have running. So let's open up Process Explorer. And this is where I'm going to get into a little bit of the debugging stuff. So like I said, you don't have to be able to replicate the things that I'm going to do. I would like the details on this. And we see, perfect. It is WWA host exactly as we expected. It's process 6712. So I can go to the debugger. I have a debugger installed. I've moved it to a more friendly location. You all have debuggers installed on the machines that we gave you. So, personally, I think the best debugging experience is a Chromeless debugging experience. So I'm going to use a command line debugger called CDB, and I'm going to attach to that process. And I already forgot the process name. Does anyone remember? 6712? 6712. Excellent. Let's see if that's the right one. Yeah, this looks right. We have a WWA host. Let me fix up the symbols really quick. Actually, that won't work here, so let's do some path. And I have symbols installed in D. We've also given you guys symbols. All right, so if you look at the USB thumb drive, there's a folder in there. It contains installs for symbols for both AMD 64, or x64, excuse me, and x86. We can take a look at this guy. Oh, I need to do some .reload, sorry. Excellent. So we can take a look at the PEB. Process execution block is, I think, what that stands for. The interesting thing here is, indeed, this is our app, right? You can see the window title here has our package ID. It has our app ID in it. The command line is interesting. It's WWA host as expected. Keep this kind of squirreled away in the back of your mind. We're gonna come back to this in a little bit. This is an important piece of information, but we don't need to cover it right now. Now, you've probably also heard that all of these Metro-style applications run in this thing that we call app container, right? Looking at the token for this process, we can see that, indeed, this thing is running as app container, right? And we have a unique package SID for our application. There's a couple other things. We have capabilities. Now, you remember in Visual Studio where we had those capabilities and the manifest UI, and you can go and check and say, hey, I use internet, hey, I use the file system, or that whole list of capabilities. That gets translated into this set. And I'm not going to go into detail as to how that's translated, but just be aware that it is there, and it's located here in the token. There's a couple other things. We have some attributes in the token. We can see that our package ID is an attribute in the token, and we can see that our app ID is an attribute in the token. Now, the key takeaway here is the process identity is strong. We have put the identity for this application into the token for this process, right? So we have a strong identity for your application. This is your app. It's running WWA host, which is a system binary, but it's your app. It's your identity here, all right? Now, this is all fine and good, but there's a slight problem here. We want to find out what's happening when this process starts, And I have an already started process, so I need to do something about that. It would be really, really nice if I could break into the process like immediately as soon as it starts. So we built a feature for that. We built a feature. It's a set of APIs. Visual Studio uses these APIs to debug your application. I have a tool that I've built in order to kind of enable this demo outside of the Visual Studio experience. So we're going to kill this guy. Actually, you know what? Before we kill this guy, we're going to run my tool. So if you can't tell, I like the command line. We're going to go into the tools directory, and we're going to take a look. And I have this debug tool. So we're going to run debug tool, enable debug, and I need that process ID again. 6712. Man, you guys are good. I can't remember the stuff on stage. Where'd my command prompt go? There it is. 6712. Ah, excellent. Very good. So it found the package name, and it set that package, it set my application into what I call debug mode. There's a slight problem. I need to tell it a debugger to launch, so we're going to do, again, our cool cdb.exe. We're going to do our cool chromeless debugger here. All right. So what just happened? I'm not going to dwell a lot on this. It's an interesting feature. You can ask me questions in the back after this if you want to know more. But basically what's going to happen here is when I launch my application, the Windows runtime infrastructure is going to launch it suspended. It's going to launch a debugger. It's going to give that debugger enough information to attach back to that process. So the next time I run this application, it's going to run suspended, and I'm going to be able to get in there and start debugging it immediately. So now we can go back to the original terminal. Now we can kill this thing because we're going to want to restart it. So that's good. Kill, detach, we can quit, debugger exits. Excellent. So let's go back. And now we get into the really good stuff. We get into how does this process start. So let's start Hello World again. And it's not doing anything, which is good, because that means this demo is working right now. We're showing the OS splash screen. This is the screen that the OS shows for your application. The application's suspended, so it can't start rendering things to the, uh-oh. That wasn't good. Let's try that one more time, huh? Maybe my debug tool didn't work. I might have to run it again. Or maybe, yeah, let's try that one more time. Sorry. We're going to actually use the package name for it this time. Hello World. There's that. cdb.exe. Sorry about that. Let's go make sure that we don't have any processes that are weird and running. Oh, did I type that wrong? Thank you. Is it running? Oh, it is running. You're right. Excellent. Thank you. Sorry, I missed that window. Ha! Brilliant. So it did work. Wonderful. Whew! I thought I was going to screw it up already. Again, we need to fix up symbols, so let's do that really quick. It's in sims. Sympath. I do most of my debugging on campus. We have a nice symbol server on campus that resolves things for you automatically. And I can reload stuff. And let's take a look at what threads are running right now. We can see that we have 2 threads running in this process. We can see that thread 0 is going to run WWA hosts startup. And we can see that thread 1 is that injected debugger thread, so we can safely ignore that guy. And just to prove to you that we are really, really early in the process bootstrap, we can dump the stacks for this thread. This is where we're going to get into a lot of debugging details. So if you're not familiar with the Windows debugger, it's OK. Just kind of follow along. I'll be explaining what's going on here. Hey, we're really early here. We haven't even started running that WWA hosts main, basically. Now, what does an application do when it starts? The first thing that the application is going to want to do when it starts is it's going to want to create this thing called a core application object. This core application object is a Windows runtime object. The OS produces it, and applications use it. And what it does is it's basically a switchboard, if you will, and it does a lot more than this. One of the things that it does is it's sort of a switchboard for activation requests. Things like activate for tile, activate for search, activate for another contract, come in through the application object. Events like your application's getting suspended, your application is being resumed, those also come in through the application object. The application object also provides a window for the application to actually render content to the screen. Without an application object, your application cannot display UI. So we know that one of the very first things that WWA host is going to want to do here is it's going to want to create an application object, which means it's going to want to use the Windows runtime. Before you use the Windows runtime, you have to initialize. All right? So we can expect WWA host to call the row initialize API to initialize an apartment before it starts to use the Windows runtime. So let's go ahead and set a breakpoint on that, and we can see if WWA host actually calls that. So row initialize is implemented in a binary called combase. Combase is our refactored core WinRT infrastructure that we provide for Metro-style applications. It's the binary that provides a lot of that functionality. So we can set a breakpoint on row initialize. And good, my symbols are resolving. Things are going really well. So, oh no. Oh, that's right. Sorry, I forgot the breakpoint command. There we go. Excellent. Breakpoint on row initialize. We can run this, and indeed we see that this breakpoint is hit. So let's take a look at where we are in this process. Let's dump the stack. We can see that finally we got around to running that WWA hosts main. It called into another one of its functions. It called into run host, right? And then it called a inline function. And finally we landed on row initialize. That's going to be kind of interesting. What is this row initialize thing doing? So we can take a look at the stack. Prefer to format it a little bit better. We can take a look at the stack, the first frame on the stack. That's what that KPN1 does. We're looking at the first frame on the stack. And we can see that we're initializing a multi-threaded apartment. Now, the Windows runtime supports two apartment models. It supports multi-threaded apartments, and it supports single-threaded apartments. Most of your application code, and I would love to go into detail, but we really don't have time in this talk, but just most of your application code is going to run in a single-threaded apartment. All right, most of your application code. We can see that the WWA host is creating this multi-threaded apartment, and now we expect it to go ahead and create that application object. All right? Now, Windows Runtime provides the infrastructure to do this activation, to actually go and figure out, hey, I want a Windows Runtime class. I'm going to get one of those guys. It's going to start running. We have two basic ways to do this. We have the activate instance route. All right? Activate instance route is class activation. It will get you back an instance of that class. And we have a factory pattern. We have an activation factory pattern, which will get you back a factory. You can call into that factory to get an instance of the class. All right? So those are the two basic patterns. WinRT also supports this really interesting notion of static methods. You've probably been looking through that API surface that you guys are starting to get familiar with. And you'll see some of those APIs actually have static methods on the class. Now, this is a really interesting thing, and this took a little bit of time for us to figure out how we were going to do this. These Windows runtime objects, it's an object-based model. We have to have some running code somewhere. So implementing static methods is kind of interesting. Like, how do we do that? How do we get you a static method without actually getting you one of the objects? We put the static methods on the activation factory. So the Windows runtime static pattern, the underlying pattern within the operating system, is to put those static methods on the activation factory. So I can tell you, and we'll see in a little bit, that application object is going to get called on one of those static methods. So let's go ahead and set a breakpoint. We have an API called rowGetActivationFactory. You provide it the class, and the API is going to get you back an activation factory. Let's set a breakpoint on this guy, and let's run up to it. So there, we hit it. So what's going on? Actually, let me show you a little bit more of the stack just so you guys believe me. Let's even go a little bit more than that. All right, so we're in that WWA host run. You can see that right here, right? It's calling some inline functions, and eventually it's getting around to calling the API we just set a breakpoint on, rowGetActivationFactory. It's saying, hey, I want this activatable class, and its name is windows.applicationModel.core.coreApplication, exactly what we expected. And it's also saying, through this parameter, I want a specific interface on that class. I don't want just any old interface. I want this interface. Give me this activation factory. Give me this interface on this activation factory. Now, You can probably suspect at this point, you saw some of the catalog work earlier, right? You saw the Windows Runtime catalog that had your application's registration. You can probably suspect that we have a catalog for all of these Windows dot namespaced Windows objects. We do. And what's going to happen is COM is going to go into that catalog, or I'm sorry, WinRT is going to go into that catalog, and it's going to look up. So, yeah, honestly, we did leverage a lot of the COM infrastructure. But it is absolutely not fair to say that the Windows runtime is COM. All right? That's like saying that a car is an engine. We used a lot of the Windows runtime or we used a lot of the COM infrastructure when we built the Windows runtime. And it's going to be plainly obvious. We're going to look at an interface in a little bit. It'll be extremely obvious that that is what we did. And it is what we did, right? COM was a technology. It was there. It's some of the underlying engine to the Windows runtime. It's not the entire underlying engine. There's a bunch of stuff that we've added here. We added that metadata. We added projections. But enough of a sidebar. I slipped. I said COM. Not a surprise. So we're going to get around to activating this class. We actually have a location where we register all these classes. And we can go back into the registry, and we can back out of here a little bit. Let's just go back up to the top of the registry. I'll start the screen magnifier again so you guys can follow along. Now, we know that your applications are per user. They're installed for each user. So it made a lot of sense to put your application's registration in HKey current user. The system-provided Windows runtime objects, all of those objects in the Windows namespace, those are available to all users, to all applications. Doesn't make any sense for us to put it in HK current user. So we actually put the registration store in HK local machine. So we can go into HK local machine. It's under software. It's under, whoops, my scroll bar's not working, Microsoft. It's under this little technology called Windows Runtime. There it is. Activatable class IDs, and there we have it. We see all of the activatable class IDs for the Windows Runtime. And this is a complete list of all the classes that you can activate for WinRT. You can see things, there's application model, devices, media, networking, storage, security, system, UI. They're all here. We're looking for a specific one. We're looking for application model, core application. There it is. Excellent. And we can come and look at the registration. This registration is the registration for a WinRT in-process class. How do I know that? It's got a different activation type, right? But activation type 1, that was out of process. This is an in-process class registration. This is how the OS understands the registration for all of those Windows runtime objects that's available for you guys to call. A couple interesting things here. Activation type, I mentioned that. The DLL path, it's twinapi.dll. This is the implementation DLL for the core application object. We can bet that we're sitting there in the debugger, right? We're waiting to get an activation factory. We're going to have to load this DLL. So we can flip back to the debugger, and I'll turn the screen magnifier off. We're done with that for now. I can flip back to the debugger window. There it is. Excellent. And I can set a breakpoint. It's not XX3, it's XSLD, twinapi.dll. Now this thing's going to break when we load that module. And it did, right? So what just happened? We went and queried the catalog, just like we always do. We found the binary to load, and we're in the process of loading that binary. Now, Martin showed a little bit of this on stage during his talk, if you were able to catch his talk. There is a DLL export that DLLs have to implement. They're going to be a Windows runtime implementation. They're going to provide a Windows runtime implementation. That DLL export is DLL get, oh, I should have done one more, sorry. Activation factory. This is the DLL export that the Windows runtime infrastructure uses to go suck an implementation out of a DLL. So we can set a breakpoint on that, and we can go. And yes, excellent, we hit it. And we can take a look at what's going on. Again, just looking at the first frame of the stack here. We can see that, hey, everything's proceeding exactly as we expected. We're calling into that DLL export saying, hey, can I get an instance of this core application object from you? And the interesting thing here is we're going to return an iActivation factory. Now, an iActivation factory is the standard factory interface for all Windows runtime objects. This interface is not the same interface that WWA host was asking for. If we come back and look, and I know this because I know this. You know this because you have all that MSDN documentation. So you could actually go and look this up and figure this out on your own, but I'm going to give you a little hint. We see that WWA host is calling into the Windows runtime, asking for an activation factory, and it's asking for a very, very specific interface. If you went online on the documentation, you could find out what interface this is. I think this is an iCore application initialization interface. It is not an iFactory interface. But this DLL export is going to return an iActivation factory. Now, why am I going through all this? This is probably like you're getting lost, you don't understand why I'm going through all of this. I'm going through all of this to explain a very important point about Windows runtime objects. To the operating system, they are interface-based. To you, while you're developing your application, they are class-based. That is the magic of the projections. It provides you a nice class to deal with. Within the operating system, we're dealing with interfaces. And we saw that, actually, I'm not sure. I'm pretty sure that some of the slides that Martin showed, you saw that objects have multiple interfaces. There's a little lollipop sticking out. There's tons of interfaces going on. Whenever we need a new interface, we do something that's called query interface. Now, this is, again, going back to that COM engine, right, that we're using. We're going to call query interface in order to get that interface that WWA host is asking for, that specific thing. Now, I'm going to show you how that query interface works. But before I can show you how that query interface works, we need to run a little bit of code here, and we need to let this DLL export actually somehow churn out a new object. So we're going to go up a frame in the stack and take a look at the local variables. Now, what did I just do? I let that function run to completion. Came back to the next frame in the stack. So we have this activation factory, and it is the thing that was returned from that DLL export. So this activation factory, whoops, wrong one. This activation factory indeed is an iActivation factory interface, just like we explained. Now, this is some more gory details for you. Interfaces really are, under the covers, are just a bunch of virtual function tables. All right? This is why the Windows runtime is so performant. Under the covers, all this is just a table of function pointers. We know the offset, we know the function we're looking for. We can go into that table, quickly find the function we want to jump to, and start calling it. We can take this virtual function table and we can actually dump it out and take a look at what methods are on this interface. So I'll take the address of the virtual function table, DPS, I'm going to dump the pointers, and I'm going to try to resolve symbols on that. That's a lot of crap. That's a lot of stuff. What is this thing? Well, it is a lot of crap. There's a bunch of templatized interface stuff going on here. This is you're seeing some of the underlying templates that we use to build our objects. The important thing is take a look at this guy. The very first method in this virtual function table is query interface, kind of like what we expected. And if we know anything about COM, we know that the next one's going to be addref. And it is. And surprise, look, there's release, right? But like I said, the Windows runtime is not COM. It is the Windows runtime. We've taken that canonical IUnknown interface, and we've added a new interface on top of it. It's called IInspectable. Martin joked around that it should have been called iKnown, but it was too difficult to kind of differentiate between the two. I think it should be called iKnown too. I think, yeah, it's a great name, because really it is iKnown, right? We have a method to get IIDs. We can get all the interface IDs that are implemented on this object. You can't do that with a COM object. We can get the class name for this guy. You can't do that with a COM object. We can go through and get trust level as another method that the Windows runtime has introduced. And then there's activate instance. So I took a little tangent, but if you recall, we still got poor WWA host sitting there saying, hey, I'm waiting for this activation factory from the application object, and I wanted that specific interface. So we know that query interface is going to get called. We can set a breakpoint on this query interface, and we can run through this. And indeed, it's hit, right? We can take a look at the stack. Ooh, that's a little bit too much stack. We'll come back up here a little bit, sorry. Query interface is being called, and we're still in that process of getting the activation factory. Now, if we run up from here, go up to the next frame, take a look at the variables. One of these variables should hold that interface that WWA host is looking for. All right? I can tell you that it's the factory variable. You could figure this out on your own by kind of poking around a little bit, but trust me for now, it is the factory, variable. Now the interesting thing is it tells us that it's stored at one of the registers, RDI, and it's a type void pointer pointer, which for my demonstration doesn't really help us much because we were kind of wondering what that interface is. Like I said, you go look it up. It's an iCore application initialization interface, but we don't care. We don't need to know because we know what the format of an interface is. We just saw it. It's a virtual function table. So if I track this pointer down, I can start dumping some memory, tracking down this pointer, and get to that virtual function table. So let's first take a look in what is at the RDI address. Okay, so that's one level of indirection. It's one pointer. There's another pointer. This guy here, this guy here should be our virtual function table. Pointer, pointer, virtual function table. So I can dump this, and if everything's working correctly, beautiful. Again, we can take a look at this. It's a lot of stuff. Query interface, addref, release, the things that we expect. Getting through the Windows Runtime required methods, we see we have this. We have two methods. We have a run and a run with background factory. WWA host is trying to run the application object here. It's trying to go find that run method and say, application object, please run. We know that one of these guys is going to get hit. I know which one. You could set a breakpoint on both of them if you wanted to. It's going to call run with background factory. So actually, before I do this, let's clear all the breakpoints. And we're going to set a new breakpoint on this guy. And we can take a look. What do we got? Brilliant. Perfect. We have the breakpoint that we want. All right. And we can run up to this. We can run up to this guy. And it gets hit. And we can take a look at what's going on. And we see that WWA host is providing two things to the application object. It's providing an iView provider. Right? Do I got the right spot? Yeah, it's providing an iView provider. And it's providing a background task factory. Now, we're not going to talk about background task. What we're trying to do is launch the application from a tile. Right? So we're talking specifically about, let's call it foreground activation. So we're going to use that view provider. So I can dump out, what exactly is this view provider? Surprise, it's an interface. It's an iView provider factory interface. There we go again with that factory pattern. So we're using that factory pattern again. It has a virtual function table, and we might as well take a look at what's in here. Interesting. There's a create view method. I bet you we're going to call that at some point. So let's set a breakpoint on that. All right, so I've been groveling through the debugger for quite a while. Let's switch back for a minute and try to recap a little bit of what we just saw. Keep in mind we got that breakpoint still set. We saw the application process come up, right? We saw the application process's main code run. Now, in this case, it's WWA host. If you were writing your own application, it would be your own application's process. We saw that main code went and initialized an MTA. That code's now running, initialized, in a multi-threaded apartment for the Windows runtime. It created a core application object, specifically through the factory activation pattern, and it called run. Now, when it called run, it provided a view provider factory to the application object. We can expect the application object's probably going to use that, else it wouldn't be provided, right? Now, I could go on debugging for hours. We don't have hours left, which is unfortunate. So Mahesh knows that I could go on debugging for hours. I asked him for a 2-hour talk. He wouldn't give it to me. So what's going to happen under the covers? What's actually happening? What's happening here, and I'll show a little bit of this. What's happening here, and I told you remember something. If we go back and look at the PEB, the process information block, we actually passed the server name on the command line. All right? So app object is going to go to the command line, it's going to get the server name, and it's going to call an API that we provide. And it's going to say, I'm running, somebody just ran me, I still don't know why I've been run. I don't know what application I've been run for. So it's going to call an API that the Windows Runtime provides and says, get me all of the classes for this server, because all I got right now is the server. I have that from the command line. We're going to return that list of classes. Okay? The list of classes, if we go back and take a look, is in the registry under software, classes. We saw this earlier. Let me turn the magnifier back on for you. The list of classes is in the registry. It's under our package. We see that we have our activatable class ID of hello world. It's in here, right? And this is the extension registration. We can go back and just as well look at the class registration for this guy. Da-da-da-da-da, da-da-da-da-da. Here is our class, hello world app ID. And we have this thing called custom attributes. The Windows Runtime also supports custom attributes on your class registration. This is interesting. Here's our default.html. It's a custom attribute for this class, right? So what do we got going on? We come back here. Let me turn this guy back off for you. We come back here. We have the server name. App object can take that server name and go figure out what classes it needs to register. And that's exactly what it's going to do. It can also use those custom attributes within the class to try to figure out, okay, what do I go and tell WWA host to do? It just ran me. I'm going to call it back on its view provider. I have to tell it to do something. What am I going to tell it? So it uses this information to figure that out. Now, what does that process look like? We covered it a little bit, right? We're going to look into the catalog, and the application object's going to get all that class information. And we still got Explorer sitting back there. Explorer is sitting over there. It's another process that's waiting for your application to start. And I'm taking a long time to get the application to start. So it's going to go register those classes with that class clearinghouse, RPCSS on the system. RPCSS is sitting there waiting for somebody to register this class. It started a process, and now it's sitting there waiting. Somebody please register this class. I have a pending activation request. Again, I can't debug RPCSS on stage. Well, I could, but it's very risky, so we're not going to do that. RPCSS calls back into the application object once that registration is done and says, hey, get me one of those classes. You just registered a class with me. I want one of those. And it turns around and it gives that instance all the way back to the activation system within Explorer. So now Explorer has an object that just came from your applications process. This is that whole, your application is just another Windows Runtime object to the operating system. It's not just a standalone executable anymore. This is a very important point. It's not just a standalone executable. It's not just an exe we started and it's off running and we don't know what's going on. We have a way to communicate with that exe. We have a way to communicate with your application. It is an object. We have an interface. We can tell it things like you're suspending, you're resuming. Eventually, quickly, the activation system is going to activate your application. It's going to call directly into app object in your process and say activate. Now, this is a private OS contract. I'm not going to go into the details of what's going on here, but this is what happens. And you're going to see that app callback. When WWA host called into application object, it registered a view provider factory. This app callback is the callback on that view provider factory. And we have that breakpoint set in the debugger, so we're actually going to be able to see that in a second. So let's take a look and see what's actually happening when we get that callback. If we come back here, we can look at the breakpoints, and we see that we do have the view provider factory breakpoint set, create view provider. So if we go, if everything's working correctly, we should hit this. And we do, great. So we hit this thing. Let's take a look at what's going on. So it's calling in and saying, hey, give me back an iView provider. Now we're going through that standard factory activation pattern again. I don't need to go into great detail and show you exactly what's going on, but I do know what's going on. And we can set one more breakpoint to illustrate, and I'm trying to remember what this is. I think this is web instance something load. Let's see if we find this thing. Ah, we did. Excellent. So if I had all the time in the world, I'd show you how we go from that interface to this method. But for now, you'll have to take me on faith. We go from the view provider factory interface and the view provider that's returned to this method. If you were to go through the vtables, you would find this. All right? So I set a breakpoint on this guy. There's a couple more interesting methods. There's initialize. Whoops, I'm sorry. That was not the right one. I want initialize. And I want one more on run. Let me get rid of that initialize shared breakpoint. It's dangerous to have breakpoints. See, that is 3. All right, perfect. All right, let's take a look here. So if we were to track down all that goo through the vtables like I was showing you earlier, we would land on these methods. All right? So let's go. Let's see what happens. We're going to go through this quick. Initialize. Let's take a look at the first frame. What's going on? Core application is giving WWA host an iCore window. It's giving it a window to display on the screen. First step. Second step. We're calling load. App object is calling load on WWA host. And look here. It's telling it you're going to load default.html. It used all that class catalog information to finally tell WWA host, this is what you're running. This is the point at which WWA host knows exactly what to do for your applications. This is the point where WWA host says, now I know about the page. I can start rendering this page, right? But before it does that, it has to get called run. Run has to be called. This is just a void function. Basically, app object saying, OK, WWA host, go do your thing. And this is where WWA host will take over, start rendering the content for your page and everything else. So what did we just see? And we're really close on time, so we'll click through this pretty quickly. What did we just see? We saw that MTA come up with the application object. Run was called. We saw the register. We went through all of that. We saw the activate. We went through that. We spun up a new thread. We spun up an STA thread. And that's what we called the view provider factory on. So your application gets a thread for each one of these activation requests. You activate for tile, you activate windows.launch, you get a thread. You activate for search, you get another thread. And they're STA threads, and your views run on these threads. So if another activation request did come in, we would see another thread spun up, but we're not going to get into that. And we would see run get called again. We'd see load and run get called. So what does this all mean? Windows Runtime is extremely fundamental to your Metro-style applications. Windows Runtime is extremely fundamental to the operating system. It's how the operating system interacts with your applications. We've built the system using the Windows Runtime, and it is a key technology for these new applications. If you're interested in more, that's about all I got today. I could, like I said, go on for hours. If you're interested in more, there's some interesting sessions to go and catch. If you didn't catch Martin Lovell's session, it's a really great session. Harry Pearson has a session. Ben Kuhn has a session. Go check the recordings of all of these sessions for more information. I'm going to be outside answering any of your questions. Finally, thank you very much for paying attention and following along. Make sure you go, forums, feedback. I'd like to hear what you guys have to say. Thanks a lot.